Extraterrestrial life. Could it be radically different from our own? Challenging assumptions about life. The search for extraterrestrial life has long been guided by our understanding of life on Earth. We look for planets in the habitable zones of stars, analyze their atmospheres for biosignatures, and study extremophiles to understand how life can survive in harsh conditions. However, this approach might be fundamentally limited. What if extraterrestrial life is so different from our own that we don't even recognize it when we see it? This question is at the heart of a growing debate in astrobiology, challenging our assumptions and broadening the scope of our search. The Earth-centric view, a necessary starting point. For decades, the search for extraterrestrial life has been based on the premise that life requires liquid water, organic molecules, and a source of energy. This is because all known life on Earth shares these characteristics. We define habitable zones as regions around stars where liquid water can exist on a planet's surface. We look for biosignatures like oxygen, methane, and other gases produced by biological activity. We study extremophiles, organisms that thrive in extreme environments like hot springs, deep-sea vents, and acidic lakes, to understand the limits of life as we know it. This Earth-centric approach has been fruitful, guiding missions to Mars, Europa, Enceladus, and other promising targets in our solar system. It has also driven the search for exoplanets, planets orbiting other stars that resemble Earth in size, mass, and atmospheric composition. However, it is becoming increasingly clear that this approach might be too narrow. The limits of our understanding. Life on Earth is based on carbon chemistry, with water as the solvent and DNA as the genetic material. But there is no fundamental reason why life elsewhere must be the same. Silicon, for example, is chemically similar to carbon and could potentially form complex molecules. Other solvents, like ammonia or methane, could support life in colder environments. And alternative genetic materials, like RNA or PNA, could store and transmit information. Moreover, life could exist in forms that we cannot even imagine. It could be based on completely different physical or chemical principles, or it could exist in non-material forms, like information patterns or energy fields. The possibilities are endless, and our current understanding of biology might only scratch the surface of what is possible. Alternative biochemistries, expanding the realm of possibilities. One of the most significant challenges to our Earth-centric view is the possibility of alternative biochemistries. On Earth, life uses carbon as its primary building block because it can form long, complex chains and rings. However, silicon is also capable of forming complex molecules, although they tend to be less stable than carbon compounds. In environments with very different temperatures or pressures, silicon-based life might be more viable than carbon-based life. Similarly, life could use different solvents than water. Ammonia, for example, remains liquid at much lower temperatures than water, making it a potential solvent for life on icy moons or planets far from their stars. Non-chemical life, beyond molecules. Even more radically, life might not require molecules at all. In principle, any system that can store, process, and transmit information could be considered alive. This could include computer programs, artificial intelligence, or even complex energy patterns in plasma or magnetic fields. Such non-chemical life forms might be difficult to detect using our current methods, which are designed to look for specific molecules and chemical reactions. However, they could be abundant in the universe, especially in extreme environments where chemical life is unlikely to survive. The importance of extremophiles, a wider perspective. The study of extremophiles on Earth provides valuable insights into the diversity of life and the conditions under which it can survive. Extremophiles have been found in almost every imaginable environment, from boiling hot springs to frozen deserts, from highly acidic lakes to deep-sea vents. These organisms have evolved unique adaptations to survive in these extreme conditions, using different metabolic pathways, protective enzymes, and cellular structures. They demonstrate that life is far more adaptable and resilient than we once thought, and they expand the range of environments that we consider habitable.
The role of astrobiology, a multidisciplinary approach. Astrobiology is a multidisciplinary field that seeks to understand the origin, evolution, and distribution of life in the universe. It combines biology, chemistry, physics, geology, and astronomy to address fundamental questions about life's potential beyond Earth. Astrobiologists study the origins of life on Earth, the conditions necessary for life to arise, and the potential for life to exist in other environments. They also develop new technologies and methods for detecting life, including biosignature detection, robotic exploration, and exoplanet characterization. The search for biosignatures, new approaches. The search for biosignatures, indicators of life, is a key focus of astrobiology. Traditional biosignatures include gases like oxygen, methane, and ozone, which are produced by biological activity. However, these biosignatures can also be produced by non-biological processes, leading to false positives. Astrobiologists are developing new biosignatures that are more specific to life, such as complex organic molecules with specific isotopic ratios or patterns of light reflected from photosynthetic organisms. They are also developing new methods for detecting biosignatures, such as advanced telescopes and spectrometers that can analyze the atmospheres of exoplanets. The exploration of exoplanets, a new frontier. The discovery of thousands of exoplanets in recent years has revolutionized the search for extraterrestrial life. These planets offer a vast array of environments, some of which may be similar to Earth, while others are completely alien. Astrobiologists are using telescopes and spacecraft to study exoplanets, measuring their sizes, masses, and orbital parameters. They are also analyzing their atmospheres for biosignatures and searching for signs of liquid water on their surfaces. The Fermi paradox. Where is everybody? Despite the vastness of the universe and the abundance of exoplanets, we have not yet found any evidence of extraterrestrial life. This apparent contradiction is known as the Fermi paradox, and it has led to many different explanations. One possibility is that life is rare and Earth is a unique exception. Another possibility is that life is common, but intelligent life is rare, and civilizations tend to destroy themselves before they can reach the stars. A third possibility is that extraterrestrial civilizations exist, but they are too far away, too different, or too advanced for us to detect. Redefining life, a philosophical challenge. The search for extraterrestrial life raises profound philosophical questions about the nature of life itself. What does it mean to be alive? What are the essential characteristics of life? And how do we define life in a way that is both scientifically rigorous and inclusive of all possibilities? These questions challenge us to think beyond our Earth-centric biases and to consider the possibility that life can exist in forms that we cannot even imagine. They also remind us of the importance of humility and open-mindedness in the search for extraterrestrial life. Embracing the unknown. The search for extraterrestrial life is one of the most exciting and challenging endeavors in science. It requires us to push the boundaries of our knowledge, to develop new technologies, and to challenge our assumptions about the nature of life itself. While we may not find life tomorrow, the search is itself a valuable journey. It teaches us about the diversity and adaptability of life on Earth. It expands our understanding of the universe, and it forces us to confront fundamental questions about our place in the cosmos. As we continue to explore the universe, we must remain open to the possibility that extraterrestrial life may be radically different from our own, and that the greatest discoveries may lie in the most unexpected places.